3 Atlas is shattering the playbook of planetary science. It isn't merely coasting through space. It appears to follow a mathematical plan that shouldn't arise in nature. Enter the 120-degree rule. While most insist it's a comet, its geometry reveals 3 razor-thin microjets spaced at exactly 120 degrees, a tripod of stability in 3D. That doesn't read like geology, it reads like design. Even NASA concedes current comet models can't reproduce it. And here's the twist that sticks with me. When teams requested high-res satellite data to verify those jet structures, the CIA blocked access. Why seal records on a Snowball? Unless it isn't one. Perhaps we're staring at a derelict device, still holding balance in the hush of deep space. Let's unpack why 3I Atlas's geometry seems impossible. Before diving in, a quick thanks to our channel members. Your support lets us push deeper into puzzles like this. If you're not a member, consider joining. It keeps this project gliding forward through the quiet. Now, back to the evidence standard models can't explain. To see why 3I Atlas is rattling astronomers, revisit the dirty snowball idea. Comets are ragged clumps of frozen volatiles and dust. Near a star, they vent in chaotic spurts, violent, messy, random. Natural comets tumble like balloons with a dozen leaks. Oumuamua and Borisov spun and wobbled, driven by uneven outgassing. 3 Atlas, by contrast, is eerily steady. Instead of a foamy spray, it shows 3 needle-like jets, and not arbitrarily placed. They're separated by an exact 120 degrees. Nature rarely draws exact. Sun-carved fissures should scatter across the surface, one dominating and throwing the body off kilter like a broken top. But 3 balanced thrust points around the center of mass? That's configuration, not coincidence. The precise tripod you'd select to stabilize a craft in vacuum. 3 thrust nodes at 120 degrees keep attitude locked, preserving intent across interstellar distances. Think of sending a camera across light years. You don't want trash bin, you want target lock. NASA's frameworks can't reconcile that precision in a natural nucleus. Calling it ice is beginning to feel like comfort clothing. It's like finding a perfect cube deep in a forest. You know it was shaped. Some suggest rare, structured sublimation. Yet the odds of 3 vents forming at perfect 120-degree spacing are vanishingly small. Then the head-spinning part. Independent teams sought high-res IR imagery to resolve the jets. The CIA flagged it under national security protocols. Why classify thermal maps of space ice? Unless those lines aren't cracks, but seams, edges of a hull. The dirty snowball story is melting, leaving a stark geometric truth. 3 Atlas behaves less like stone and more like a machine. If it's a machine, who powered it up? There's also the rhythm. 3 Atlas isn't frozen in place with static plumes. It pulses and nods. Using the Larsen-Scanina filter to peel away the coma symmetric glare, astronomers expected a crumbling core. What emerged looked like a heartbeat. The entire jet system oscillates by 20 degrees every 7.1 hours. That 7.1-hour cadence functions like an internal clock. It behaves like a lighthouse, beams sweeping with mathematical regularity, brightness modulating with each rotation. The more you examine the spin, the less random it feels. The rotation axis isn't arbitrary either. It's oriented almost directly at the sun, within 10 to 20 degrees. It looks like intentional star locking. This reads like active attitude control caught in the act. In spacecraft engineering, you don't let a probe tumble. You use thrusters to tame gravity gradients and solar pressure. My colleague, Dr. Frank Loyan, posed a question that stuck. Why 3 jets? We often use orthogonal sets, 6 thrusters in opposing pairs, to cover all axes. But if a body already spins about its principal axis, you don't need 6. You need the minimal array to trim tilt. 3 jets 120 degrees apart are the most elegant, energy-lean solution to stabilize a rotating mass in 3D. Minimum viable propulsion for a craft traveling eons through the dark. Seeing that exact geometry on a comet is like finding a functioning gyroscope in a pile of coal. And then there's the fourth contributor, the sunward beam, the anti-tail. While the trio balances, this dominant lance points straight at the sun, stretching an order of magnitude farther. Some suspect a primary drive or a collector paired with secondary stabilizers. In common science, jets point anti-solar, pushed by solar wind. 3 Atlas counters, projecting toward the furnace that should be stripping it. The leaky ice picture struggles to explain why these flows form surgical needles instead of broad, ragged fans. Comets lack primary-secondary architectures, no attitude adjustments, only crumble.
On January 22, 2026, a rare vantage opens. Earth will line up nearly exactly with 3 Atlas's anti-sunward direction. For a short interval, we won't view it sideways, we'll be staring down its path. If the 120-degree thruster model is right, those 3 microjets won't resemble random tails. As the body rotates, each will trace a perfect circle on the sky from our perspective. A circle drawn in gas and dust. In the raw, unruled wild of space, nature doesn't sketch perfect rings with fire. That's the part that gets under my skin. Compare with 67P Churyumov-Gerasimenko, Rosetta's lumpy cosmic potato. It spat dust in all directions like a broken sprinkler, gorgeous chaos from uneven melting and jagged vents. 3 Atlas isn't spraying, it's emitting. Not broad fans, but ultra-thin filaments that hold coherence for thousands of kilometers.
Some pushback. Maybe 3 deep fissures happen to be equally spaced, a freak structural quirk. One fluke is curiosity. 3 identical flukes at precisely 120 degrees are pattern, and pattern is the earliest hint of intention. A growing hypothesis, championed by researchers like Avi Lobo, is that these aren't just gas plumes, they're exhaust. We could be seeing the byproduct of a high-efficiency drive that slumbered for ages, now roused by sunlight. What if our star didn't merely warm ice? What if it woke an ancient sensor? What if this triple signature marks a system regaining balance after eternity on standby? It's a haunting picture, a forsaken artifact far from its makers, still following its program, still stabilizing in the black. That's the difference between a landslide and an architect. A landslide is accident. An architect leaves lines that add up. What rattles me most is our response. We instinctively file everything under natural until the evidence corners us. We'd rather bet on a 1 in a billion fracture pattern than concede we might be staring at someone else's scrap or treasure. But the triple signature isn't interested in comfort. It's math etched on night. If that circle appears on January 22nd, we won't be watching a comet. We'll be witnessing a geometric ghost, perhaps from a civilization long gone, announcing itself with the simplest language, 120 degrees. How many such ghosts drift just beyond our current courage to notice? Often the void's silence isn't the absence of voices, it's our failure to listen to shape. I don't know if 3 Atlas will ever say hello, or if anything remains within that lattice of lines. But as it slides back toward the deep, it leaves a lingering question. If this is a machine, how many more lie out there? Are we living amidst a celestial graveyard, the husks of explorers who reached for the stars millions of years before we stood upright? We keep seeking biology that looks like us, while overlooking technology that outlives its makers. As this visitor dims, remember, we're a footnote in a far older story. The dark isn't empty, it's dense with history we've yet to read. If the 120-degree riddle fascinates you as it does me, please subscribe and leave a like. It truly helps us stay on course as we navigate these mysteries together. And if you'd like to go further, becoming a member makes a real difference. Your support lets us ask the questions others won't. Until next time, keep your eyes on the quiet. You never know what's looking back.